Welcome back to Seacoast High School's remote trigonometry class. My name is Eric Fearing. I use he, him pronouns, and most of my students just call me Mr. Today we're working on Competency 1 Benchmark 4, which is really a prerequisite for some of the other things we're going to do. It's a review of the Pythagorean Theorem. You've probably, almost certainly, used the Pythagorean Theorem a bunch of times. It's one of the most famous of the formulas that gets used in math classes. A squared plus b squared equals c squared. Now, that's nice and short, but it only applies in certain situations. That's when we have a right triangle where the hypotenuse is c. The legs are interchangeable because the order you add a squared and b squared in isn't going to make any difference. I sometimes like to use a graphical representation of this to help me finish my problems. So when we think about squaring something, we're multiplying it by itself. That's like finding the area of a square. So we can sketch ourselves a square that would be a times a, and we can sketch ourselves a square that would be b times b, and we can sketch a square which is harder to do on the diagonal and maybe goes off the top of your paper, to be c squared. And if we know two of these things, we can find the third one. And that's what all these problems are going to be about in this lesson's problem set. As an example, I'm going to do one of the more important triangle problems for this course. We're going to start with an equilateral triangle with sides that are all length 1. And we're going to find out how tall it is using the Pythagorean theorem. So what we have here now is a right triangle with a base of 1/2 and a hypotenuse of 1. We don't know what the height is necessarily, but we can use the Pythagorean theorem to find out. C will be 1. I'm going to replace B with H. That's the thing we have to find. And A is going to be 1/2. So 1/2 squared plus the height squared equals 1 squared. We just do a little bit of algebra here. 1/2 times 1/2 is 1/4 plus the height squared equals 1 squared, which is just 1. Then we take away 1/4 from both sides of our equation to give us the height squared equals 3/4. Here's the step that you may not remember. The inverse operation for adding is subtracting. The inverse operation for multiplying is dividing. The inverse operation for squaring something is taking its square root. You can write the 2 in the radical symbol or not, your choice. We know our answer is going to be positive because it's a height, so I'm just worried about a positive times a positive that makes 3/4. The simplest way to do this is to take the root of the numerator and the denominator and say the square root of 3 over the square root of 4, which is 2. And so we find the height is exactly the square root of 3 over 2. We're going to do some decimal problems, and then you'll use a calculator to find the decimal approximation of this. But we're going to see this number a few times later in the course, so I wanted to go through it here as a method to find what that height was. Let's do a couple of the decimal problems now. So here we've got our right triangle. We have 2 known legs and we don't know the hypotenuse. We can just call that C. I know 3 squared plus 6.5 squared will equal C squared. 6.5 squared isn't something you might know off the top of your head, so grab a calculator. I would suggest going to desmos.com/scientific and then we're going to use this calculator a few times during this class because it has all of the functions we need. So I'm not sure what 6.5 squared is off the top of my head. You can type it in or tap it out on the keys here and then hit a squared, which just squares what our answer was. So this square to the left, 42.25 area. I do know that 3 squared is 9. That one I could do quickly. But 9 plus 42.25 equals c squared gives us our algebra. 42.5 plus 9 is 51.25 is c squared. And now to get the value of c, we know the area of this box is 51.25, but the length of the side, we need to take the square root of both sides of our equation. On Desmos, you're going to type the radical key first, and then you can either type in 51.25, or you can hit this button that says ANS. That inserts the answer. So now we see the square root of 51.25 is 7. Let's go to 2 decimal places, 16 will be C. This one's one of the easier problems where we know the 2 legs and need to find the hypotenuse. We don't have to do much solving like we did in my first example. Here's a problem where we don't know the leg, but we do know the hypotenuse. I assure you that we're pretending this is a right triangle so that we can use Pythagorean theorem in the first place. So here we know one of the legs is 4.1. If we square that and add it to the unknown leg, which I'll call x this time instead of a or b, it's just a letter, doesn't matter, equals 4.9, the largest side, squared. And we're going to go to Desmos. And we need to do 4.1 squared, 16.81, plus x squared equals 4.9 squared, 24.01, and now we'll subtract 16.81 from both sides. Get 7.20 and take the square root. Desmos, we want to hit enter first, take the square root of the answer. X equals 2.68. So we found that missing leg. It did require a little subtraction. If you want to do this in a different order where we don't have to do all of the typing and carrying the decimals around, we can think about this from the beginning. 4.1 squared plus x squared equals 4.9 squared. And we can take away 4.1 squared from both sides and get x squared equals that expression, 4.9 squared minus 4.1 squared. And we could take the square root of that, which maybe makes it easier to type into Desmos, maybe not. I leave that opinion to you. The square root of 4.9 squared minus 4.1 squared. Make sure the whole thing is inside the square root if you're doing it this way, and you find the same answer, of course, 2.68. So there is your review of how to use the Pythagorean theorem to solve problems where you're missing either the leg or the hypotenuse. you should be able to apply the Pythagorean theorem whenever we know two sides of a right triangle. We're going to make that happen a few times later on in the course, so we wanted to go through this review. Thank you.